Hello guys, welcome back to my channel and welcome to the new interesting video where we are going to talk about a real-time use case. We are going to automate S3 ETL pipeline by using AWS Glue, and we are going to deploy that by using Terraform. So as part of this video, I have broken down this video into 5 sections. So as part of the first section, I would give overview of the AWS services that we are going to use, which would be AWS Glue, AWS GlueCatalog, and AWS Glue Crawler. Then I would move to the section 2 where we are going to build 3 S3 buckets. One would be the source S3 bucket, the second one would be the destination S3 bucket, and the third one is going to be a code bucket where we are going to save the code of our PySpark script that we are going to create for AWS Glue job. Then we would move ahead to section 3. As part of section 3, we are going to create AWS GlueCatalog and AWS Glue Crawler, which is going to fetch the data from our source S3 bucket. Then, as part of section 4, we are going to go ahead and create IAM role for the AWS Glue job, which is going to perform the ETL operation for us. Then, as part of section 5, we are going to go ahead and we are going to build the AWS Glue job, and we are going to write the code of the PySpark script, which is going to perform the operation of picking the data from the source bucket, processing that, and pushing it back to our destination bucket. Without wasting much time, let's go ahead and jump to the screen right away.
Hello guys, welcome back on the screen. So let's view the agenda for today. So today I have divided our tutorial into 5 different sections. First, we are going to go ahead and see overview of AWS Glue, GlueCatalog, and Glue Crawler. Once we see the overview, I will also give you a diagrammatic representation about what we are going to implement. Then we will start building our Terraform code for the same. First, we will build our Terraform template for the buckets, where we will create 3 buckets. The first bucket would be the source, the second one would be the destination, and third one would be the code object. Along with the creation of these buckets, we will also create the objects which would be added as part of these buckets. Okay. Then we will go ahead and to the point number 3. So in 3, we are going to create GlueCatalog and Crawler. These are going to fetch the metadata from the S3 bucket and store it as database, and Crawler will crawl the data and make it available as a table. Then as part 4, what we will do is we are going to create an IAM role for AWS Glue job. So this AWS Glue job IAM role is going to provide permission for the Glue job to perform the ETL operations end to end from one S3 bucket to another S3 bucket. Then last but not the least, we are going to talk about how we can build the PySpark script for the same, and we would also create the Terraform template where I would be writing the code how we can create a Glue job, and we will attach that specific PySpark script to that Glue job. So let's start with our agenda, point number 1. So in section 1, we are going to have an overview of the 3 important services that we are going to talk about all around is these. The first one is AWS Glue. So what is AWS Glue? It is a fully managed extract, transform, load service that simplifies and automates the process of discovering, preparing, and combining data for analytics, machine learning, and application development. So AWS Glue offers a lot of services as part of the AWS Glue console. Let me show you that. So guys, let's go to the AWS console. So see, this is the AWS Glue console where you will see there are so many options available in terms of ETL job, visual ETL job, notebooks, data catalogs, data connections. Over here you have a separate different segregations for data integration ETL. So this is the Glue template that you would be using going ahead if you are working from the console. Now going back to our another service, that is Glue Crawler. So what is Glue Crawler? It is a tool that automatically scans the data from the source, and that source could be a S3 bucket, it can be a RDS service, or it can be a DynamoDB table. So to infer the schemas and create metadata tables in the AWS GlueCatalog. So what AWS GlueCatalog is, in AWS GlueCatalog, there is a database which gets created, and in that database, there is a table which has to be created with the metadata, which are going to be the column names. So those would be crawled and pushed to GlueCatalog by Glue Crawler. Okay. Now going towards the third service, that is GlueCatalog. So AWS GlueCatalog is a centralized metadata repository that stores and manages metadata for all the assets across various data stores, and it serves as a unified catalog for organizing and accessing data, making it easier for users to search and find the data they need. So Glue Catalog is going to be a table which is going to hold all the metadata that has been crawled from the S3 bucket into the catalog. That I will show you very soon, but just for a glimpse, I will take you to the screen of our catalog. So this is the database. So this is the Glue Catalog. Okay. So over here a database would be created, and this is the crawler. So once it will only show the database. Now inside the database, the table, the metadata which is supposed to be created is to be created by the crawler. So when we are going to create both of the service, I will show you the crawler will start running, and once it completes, it will push that data over here and the table will become available. Now, so that is the overview of the AWS services that we are going to use. Now moving forward, let's understand what we are going to implement. So we are going to automate S3 data ETL pipeline with AWS Glue using Terraform. So what is the journey that we are going to go ahead with? We would be storing one file into the S3 bucket. Once that file is stored in S3 bucket, then our Glue Crawler and Glue Job, these both services will be created, and once this service is created, it will just create a database to store the metadata of the S3 bucket CSV file that we have put over here, and the crawler will fetch the metadata and it will share the metadata to AWS Glue Catalog. So once it is available in Glue Catalog, then we will be going ahead and creating a Glue Job. So once you create a Glue Job, what that Glue Job is going to do is it is going to source that data from Glue Catalog. Once the data is sourced, then it will we will create a PySpark script. So what is that PySpark script is going to do is it is going to transform the data. So for example, right now if we pull the CSV file and if we process it, so suppose if there are 100 columns into that specific CSV file and you just need only 10 columns to be utilized from your end. So in that case, what you would do in the PySpark script, you will simply mention that please remove all the other columns and just have this. So there will be a PySpark script code over there to process the data. So once it is processed, what it will do is then the Glue Job is going to go ahead and push that data into destination file. Now it depends on your requirement. So at the current moment, I have taken the input as CSV, and I have also added in the destination file the output as CSV, but it's not specific to that. If you want, you can also keep it as Parquet or some other kind of extension file that you would require as per your industry level use case. And the most important part, the IAM permission. So when you're going to run the Glue Job and it is going to source the data, it is going to process the data, and it is going to push into the S3 bucket, you should have appropriate permissions as part of your IAM role. If your IAM role is going to have that permission, then only then you would be able to push your data into the destination file. Now let's see our step number 1 for building our today's tutorial. So first we will build three buckets. The first will be the source bucket, where we will keep our raw input data, which is a CSV file, and the AWS Glue Job would read the data from this bucket, and it will perform the operations, and it will convert that file based on our requirement and push that to destination bucket. And what is destination bucket? In this bucket, you will have the process data that we are going to create. What is code bucket? The PySpark script that we are going to create, we are going to store that PySpark script into code bucket, because when we are going to create the Glue Job, as part of that, we are going to have that script utilized from that specific S3 bucket. Okay, so without wasting much time, let's see what is our next step. So let's start with the basic configuration and jump to our Visual Studio Code. So I am on our Visual Studio Code, and we are going to talk about providers file, variable files, and version files. I will open all of them: variables, versions, and providers. So in variables, I have defined that we are going to implement this exercise in US West 2. In version, we have mentioned the version of Terraform, and in providers, we have mentioned that what is the provider, and I have shared my AWS credential based on which Terraform will communicate with my AWS account. Now, moving back, so let me close these 3 files for now, and we will start with our first step. And what's that first step? We are going to create our buckets. So let's understand the code for our bucket. So the first code says that we are going to create one tutorial source data bucket, and this is the resource name, and I have kept the bucket name also same. Now I have mentioned an argument over here which says force destroy. why this argument is required? Because when you perform Terraform destroy, and if you have any object or file into that S3 bucket, it will not be deleted. So to allow Terraform to delete that, we have to enable this argument as true. Now, as part of the second, this is a data object. So as I said, once we create the S3 bucket, we are also going to go ahead and add the files onto that specific S3 bucket. So the organization, so organization.csv is our sample data file that we are going to upload over here. So once it is uploaded, I will take you over there and I will show you that what data it has from the S3 bucket itself. So there is a very good functionality where you can actually perform a query onto the files that you have into the S3 bucket. I will show you that after we push this S3 bucket. Okay, then so that was for our what we say. So that is for our source data. Now let's move back. I will minimize this. We have covered. So let's talk about the target bucket. So in target bucket, we don't have to create any object. So we only have a creation of the S3 bucket, and it has just two properties: the bucket name and the argument to enable force destroy. And I will minimize this. Then the third one is our bucket where we are going to save the code. So we are going to create a tutorial code bucket. This code bucket is going to save the code like PySpark script, or if you have any other kinds of code also, while you are creating a CI/CD pipeline, you can store that code into that S3 bucket also, and you can utilize that from that specific S3 bucket. That is the best practice that we follow into companies. Now, moving forward, this is the object where we are pushing the script onto the S3 bucket. So as you see, so this is our bucket.tf file. So what I will do, so let me just check the other files, yes, and see if those are commented, because I will take you step by step. Yes, these are commented. So we will take it as part of our next section. So now as we have our code ready, I will jump to the terminal. I will just clear the screen and write. First we will go to the specific folder that we have created, which is cd glue job s3 read write. Once we are in the folder, so right now you don't see any Terraform folder over here. So we will run Terraform init, and once it is done successfully, you will see, yeah, so there is a Terraform file which has been created, as well as a Terraform log.html file. Okay, so let's jump back to our terminal. So our first command was successful. Now let's run Terraform init. Oh, sorry, I ran the command once again. I will run Terraform format, so it will format if there is any issues. Okay, the bucket file was having some formatting issue, it has been formatted. Now I will write Terraform validate to see if there is any configuration issues with my file. Okay, so there is no configuration issue, but yes, there is some deprecation of resources. Maybe later on I will try to change that into my code that I'm going to upload on the GitHub. Now we will write Terraform plan to understand if it is going to create all those resources. So here is a Terraform plan. So we can see 5 resources are going to get added. Let's see what are these 5 resources. So it is going to create tutorial code bucket, then it is going to create tutorial source bucket, then it is going to create target data bucket, and then it is going to create the code data object. And the data objects are there. There are 2 data objects and there are 3 buckets, so total it is 5. Okay, so I will just go ahead and clear the screen and run our final command, Terraform apply auto approve. So it will just go ahead and create our S3 buckets for us now. So it is creating. Okay, so the creation is complete. Let me clear it and let me minimize this. Let's jump to our screen. Let's go to the console to cross verify our S3 bucket, and I will sort the S3 buckets based on the creation date, and based on the today's date, it will be the 3 buckets: code bucket, source data bucket, and target data bucket. Now in source data bucket, that should be one file. I will show you that file. This is the file. So what I will do, I will click on this, click on action. There is one functionality that would be useful for you. So by using this, you can perform a query to see what data that specific file is holding. Run SQL query, and here is the data. So see guys, so this specific file is holding 100 records. Okay, so why it is showing 101? The first one is a column, so ignore that. So this is the column. So what are the columns? It is our columns are holding index, organization, ID, name, website, country, description, when the company was founded, and industry name, number of employees. So this is the data that our organization file is going to have. Now let me close this. So our S3 bucket has been created successfully. So let's see what we are going to explore in our next section. So our next section is all about AWS IAM role. So previously we saw how we are creating the S3 bucket, and we defined our basic configuration files, and now we are going to talk about the IAM roles. Why we are talking about the IAM roles? Because these are the main building blocks which will provide you permissions to communicate with other services. So we are going to create one IAM role, and that IAM role is going to have the trust policy, as well as that IAM role is going to have the appropriate permissions, so it can communicate with multiple services while the Glue job is going to perform the ETL operations. So let's jump back to our screen and explore what our service have. I will just go ahead and comment it, and let's see. So this is our Glue service role that we are creating, and over here is our trust policy that you can see the assume role that we are passing in our trust policy. Then we are creating a role. So this is the role. We are creating the role policy, and as part of this role policy, I have given all the roles which is required to be performed over here: CloudWatch and create bucket, get object, put object, create object. So these kinds of all operations has been explicitly mentioned over here. So let's perform Terraform plan and see how many resources it is going to add now. So you can see it is adding two resources. One would be the role and another one would be the policy. So this is the policy that we have, and this is the role. Now I would just go ahead and perform Terraform apply command. So our resource creation is complete. What I will do, I will go back to AWS Console and we can check AWS IAM roles, and over here I will go back and see our role that has been created, Glue service role. Search for it. Yes, it has been created successfully, and if I go into the policy and expand the policy, yes, the policy is as we have defined. Now let's go back. Okay, so let's see what is our next step. So next we are going to build AWS GlueCatalog and Crawler. So previously I gave an overview about both of these services, but now I will explain you in detail what exactly the service does. So Crawler is the service which is going to inspect the data determined in the S3 bucket that we are targeting to. So for us it is S3 bucket. It can be RDS or DynamoDB table also. But I will talk about CSV. So you can take an example that it will actually determine the structure of the CSV file, the data types of the CSV data, and any potential partitions which is there as part of that CSV file. And this helps to keep the catalog up to date. What we mean by that is it's the job of the crawler to fetch whatever changes comes in and to update the GlueCatalog table so that the data which is being fetched by our Glue job is up to date. Now GlueCatalog. So in catalog, as I was telling you guys, there would be a table which would be created, and in that table whatever metadata which is supposed to be added, it is going to be passed from Glue Crawler, which will have the details of all the columns of the CSV file that you have created, as well as it will have details of the type of that specific column. So for example, the ID would be integer or something would be string. So everything would be defined over there. And as this GlueCatalog service is cloud native service, it is not only for integration with AWS Glue job, it can be integrated with other analytical services also. So that is the beauty of the cloud native, I would say, services that AWS offers. So now I will minimize this. We will jump to our crawler and catalog. I will uncomment my code and we will understand it step by step. So first we will talk about catalog. So over here what I am doing, so as part of catalog we are creating a database which is named org-report, and the data for this org.report is going to come from the source S3 bucket, and I have mentioned the source S3 bucket over here. So what is this? This is interpolation. So AWS S3 bucket, it is referring to over here. So it is the interpolation, AWS S3 bucket and the bucket name. See, right? So that is how it is, and .id. So that is the attribute which has been returned to location.uri. So once the table is created, then we'll go to crawler. So in crawler, first we are going to give the name of the crawler, that is org report crawler, and database name we are going to give the same AWS GlueCatalog database. So we are again using interpolation where it is fetching the data from another resource. In role, we have defined the IAM service glue job role, which is going to provide it permission to fetch the data from S3 bucket, process it, and pass it to GlueCatalog. And as part of the S3 target bucket, we have actually added the target bucket also over here into the Glue crawler. And the schema behavior we have also mentioned as we can log that schema behavior, as well as we have also provided some basic configuration. So these are the basic configuration, but if you need more configuration to be added, that configuration you can add by yourself by going to the official documentation, and you will see. So right now I've just added grouping, but it can be more. Now speaking about the third resource, so right now the crawler. So as soon as the crawler is created, it will not run automatically, right? So what I have done, I have kept the trigger of the Glue crawler as on demand. So what happens as soon as this is created, so this action is performed where it is going to perform start the crawler automatically, and it will generate the table and pass it to GlueCatalog. So let's go ahead and clear the screen. And Terraform plan. So at the current moment, it should create 3 resources. So yes, it is creating 3 resources. So let me run apply now. And while it is being created, let's go to our database. I will refresh it. It will reflect over here also. So this is a database that we are going to create. First it will create database, then the crawler will fetch the data. So let's see, take some time. Okay, so it has created. So I will just refresh. So guys, see, the database will be created now. Oh sorry, my bad, we are checking that in the wrong region. We are supposed to be US West 2. Okay, let me go. So guys, see, the table is created and the crawler is running. Okay, so over here, so it takes some time for the crawler to run. So if I go in org.report, so you will see the table is not yet created over here. Okay, so once this crawler is going to complete, then and only then you will see a table will be created under this database, that is org.report. So this is the metadata which is going to be referred from our Glue job. So you have to wait for a while this is running. It takes around 3 to 5 minutes. So it is going in stopping state. So let's see now. The table is created. Yes. So guys, if I click on this table, you will see the entire metadata. See the table overview, the column names, and it has mentioned the data type. And is there any partition key? No, there was no partition key mentioned in our CSV file, so there is no partition key. So every of these details into the table was crawled by our crawler. Now, just remember, when you are actually creating this resource, right now I am breaking this down into multiple steps, but when you're going to create it together in one file, you have to add a dependency on crawler along with the other steps, that is creation of Glue job. The reason for that is the Glue job will not create because the crawler is running. So crawler has to complete its operation, then and only then the Glue job would be able to connect to the GlueCatalog, because right now it has established connection with the GlueCatalog that the Glue job is supposed to communicate with. So it is ready. So now let's see what's our next operation. So now we are going to talk about two things. So Glue job I have spoken a lot, so I won't speak much about it. So now we are going to talk about the PySpark script. So this PySpark script is the transformation. It is going to perform the ETL for us, which is going to fetch the data as object, process that data, and push it back to our target bucket. So it is a Python-based script which is using the Apache framework to perform data processing. And the script reads data from specified S3 bucket, applies transformation that we have mentioned, and data processing logic, and writes the processed data to another S3 bucket. Okay, so that is what PySpark script is for in this specific exercise. So let me go ahead and jump back to our Visual Studio Code. So let's minimize this and let's go to our. First, I will show you the script and explain. So guys, these are the libraries that we need to import. Now, first and foremost, what it is going to do is it is going to this argument is getting the job name. Okay, so once the job name is it is getting an argument as a job name, then it initializes the Spark context, Glue context, and Spark session. So these are the three methods that has been initialized. Then it will create a Glue job. So once the Glue job is created, it says job is equal to job Glue context. So it fetches the context of the Glue that has been passed. Then a job.init arguments, it gets the job name as well as the argument associated with that specific job. Then moving to next, so over here now it is going to get the data from the catalog. So it says that script generated for the node AWS data catalog. Over here we are passing the details of our database name, database table. Okay, and this is the same transformation CTX is the name that you have mentioned over here. So as part of this, you have a dynamic frame from catalog. We are providing data which will help them to fetch the data. So once we are having that data, so we are going to pass that dynamic frame to our next step where script will generate the chain schema. So over here in chain schema, we are doing apply mapping. So apply mapping, what we are going to do is we are going to take the input from GlueCatalog and then we are going to map that. So now it is performing the mapping one by one. So whatever columns we got in GlueCatalog, it is mapping it over here. So over here it is changing. So previously over there you saw that the type of index was big in it. Now it will be long. So I will show you once our data has been written. So this is the change. The same way if you want to make any changes. So suppose for number of employees, right now it is long. If you want to make it as integer, you can make it as integer. So based on your requirement, you can just keep on changing it. Okay. So this is a transformation step where you can define what kind of data you want to be transformed and pushed to your second S3 bucket. Now, going down, what is the third step? The third step is it is going to get that data from chain schema node. So this time, this is this chain schema. We are passing that as part of frame. Now we are telling that the connection type is S3 and the format is CSV, but you can change the format to Parquet or other formats which are compatible before pushing it to the target bucket. So I have mentioned the format as CSV and the target as target bucket without any partition keys because we don't have any partition key. And transformation CTX is the same as AWS S3 node. And at the end, we are going to just say job.commit. And this is going to perform the operation for us. Now, this is the code that we spoke about. That is a PySpark script. Now, I will take you to the job. So this is the job. Okay, I will just uncomment it and I will explain you what exactly. So over here, for this job, first of all, to perform all this operation, you would require appropriate role. So we have assigned that appropriate role to the job. We have given a description of the job, the Glue version on which it is going to run, the worker type of Glue, the timeout. We have set max retries. So if the job fails once, it will try it once again. Number of workers we have given 2. You can define as per your requirement. And the Python version we have given 3. And the script location over here we have mentioned. So based on which it is. So the script that I told you. So if you go over here in bucket object, so this script has been uploaded as part of an object into the tutorial code bucket. So that is what the location I have provided, and it picked the file from here. Now over here I have enabled some arguments. So what this argument says that we can enable auto scaling. we have to enable continuous CloudWatch logs, because when the job is running and if you want to troubleshoot if there is any error, the CloudWatch logs should be created. Then we have source path of the file. The source path of the file is source S3 bucket URL, and the destination path is target bucket URL. Okay. Then the job name that we have defined in the default arguments, and enable continuous log builder we have kept to, and enable matrices. What is matrices? So whenever we are creating the job, I will show you in the console also. So there are some matrices which are being created over there based on which it works. So let's go back to our terminal and perform Terraform format any file. Okay, one file was formatted. Then I will write Terraform plan to see if we are having any error before we implement it. Okay, so we don't have any error, and you can see only one resource, that is Glue job, is going to be created. So let me just go ahead and clear the screen and run our apply command, the final command for completion of our today's tutorial. So guys, the job has been created. I will take you back to the console. So this is the AWS Glue console. I will go to ETL jobs, and let's see if our job has been created. We are in US West 2, 0 jobs. Yes, tutorial Glue job. So this is the job which got created. I will click on it. So this is the script that we have mentioned. See, everything end to end. And over here I have not set any trigger, so it is not going to run it automatically. You have to go in onto the screen and run it. Otherwise, you have to mention that as part of your configuration in Terraform. So these are the job details that we mentioned: Spark, Glue version, Python 3, then CloudWatch monitoring, and everything has been mentioned over here. Number of workers, advanced properties like C. And if you want, see, continuous login, you can enable that also. And see, whatever parameters we have passed it over here. All parameters are also here. So let me just go ahead, and so in runs, we have not run this job at all. So let me go ahead and run the job. So it will usually take 1 minute to complete. So the successfully started the job. So now the job has been successfully started, and this is the argument that has been mentioned. Meanwhile, I will just walk you through about the details that we have mentioned. Now continuous log, it has not yet started because the job is about to start. After a few seconds it will start for sure. And the same with the insights. So let's wait. See, matrices has started loading, but for continuous log it will take some time, because till now the job is running. Meanwhile, I will also check. So over here you can see, so this seems to be an old file. I will delete this file. Okay, so the job is still running, and if you see, no, the continuous log is part of advanced monitoring. Continuous login is enabled, but maybe it's taking some time. It usually does not. Let's refresh this. Yeah, so job has successfully been completed. If I go to the S3 bucket, so I assume this is the old file. If I refresh it, yes, there is a new file, and this is the latest one. So let me just click on it and perform a SQL query for you guys to show whether it is able to fetch the data. And guys, as you can see, over there we had 100 records, and over here again we have the 100 records with the modified data types that we want. Either you can also remove the columns if you don't want it. Any changes you want, you can just make to that sample code that I have provided you, and that helps us conclude our exercise. And last but not the least, guys, once you have implemented this, the most important step: don't forget to perform the destroy command and destroy all your resources. Otherwise, you will be billed for the same. So thank you for your attention. And last but not the least, I will just walk you through the blog that we have published for the same. So guys, here is the blog. In this blog, I have defined everything. So we have first given the overview of what all services we are going to use, then why the pipeline is required, what is the industrial level use cases. Then the Terraform configuration setup, where you will be setting up the variables. You can set up the AWS provider, the basic files, then the S3 buckets, then the service role. So everything is clearly mentioned over here that you can actually use as part of this entire tutorial that we have done. So people who are more comfortable into by reading and doing it practically. So thank you guys for your time, and stay tuned for my next video. And if you have any comments, don't forget to share your comments or queries in the link of the description below, and I will be happy to assist you. Cut ho jayega ye. I would be happy if you have any queries to be answered. So put your queries and comments in the comment section of the video below, and I would be happy to assist you. Thank you guys, and have a great day ahead. Goodbye.